In this problem, I want to find the radius of gyration for the pendulum I have here that has a 12-pound plate connected to a 4-pound rod. And I want to find the radius of gyration from the moment of inertia about 0.0 as I have here. Okay, so again, I'm going to use the parallel axis theorem this time for the mass moment of inertia, okay, which is the moment of inertia of the mass about its centroid plus the mass times the distance away the centroid is from 0.0. Okay, so I start with the rod here, okay, and the moment of inertia of a rod about its centroid is 1/12 ml squared. So I get 1/12 m, which is 4 pounds, divided by 32.2 to turn it into slugs, and its length is 5 squared. Okay, so that's the moment of inertia about its centroid, and its centroid is at 2.5, which is a half of a foot away from 0.0, because 0.0 is 2 away from the endpoint. So I take that, okay, I take the moment of inertia about the centroid, and I add it to the mass, which again is 4 divided by 32, times the distance away, which is 0.5 squared. Okay, moving on to the plate, its moment of inertia about its centroid, located right in the center of the plate, is 1/12 mass times length squared plus width squared. Okay, so it's 1/12 mass is 12 divided by 32.2 to get into slugs, and then I've got 1 foot squared plus 1 foot squared. That's the moment of inertia about the centroid of that plate. I take that plus the mass of the plate, 12 divided by 32, times the distance away the centroid is from 0.0, which is going to be 3 to get to the edge, and then another 1/2 of an inch to get to the center. So that's where the 3.5 squared comes from. Plugging that all in, I get moment of inertia of about 4.9 slug foot squared. Okay. Now, the radius of gyration is, again, the square root of that moment of inertia divided by its mass. So I just find its mass simply by adding 4 and 12, dividing by 32.2 to get into slugs. I can find the total mass of this object to be, about a half of a slug. Okay. Then using the equation for the radius of gyration, which is just the square root of I over m, I just plug those values in, and I get radius of gyration of 3.15 feet. And again, the radius of gyration is effectively the distance away from 0.0 that I'd have to put all of the mass, all of that 0.5 away to get the same moment of inertia. So it's just another way of defining the distribution of the mass. So you think about it as if I was going to have a ring, okay, where all of the mass was at a fixed distance away, making a ring of a 0.5 slug, what would the size of that ring be? And it would be 3.15 feet.